Welcome to Khetz tutorials, and in this video I'll be covering question 29 from A exercises in James Stewart calculus. So this is our question. So asked to solve the inequality and draw a solution on a number line. And now how we'd normally do this is we basically factorize, find critical values, then determine where you have negative and positives. In this case, we're looking for places where this graph or this function, quadratic equation, is greater than 0. In other words, where it has positive y values, right? And to do that, as I said, we just basically find critical values and then determine which intervals satisfy this condition. Now, in this case, it's not so clear-cut, and just to let you know, there are no critical values or roots for this equation. You can try to factorize it. You basically can't do that directly because it does not have x-intercepts. So that's a giveaway for the question. So then how do we answer this question? Let's get right into that. To answer this, we're now going to convert this quadratic equation into its standard form, which gives you more information about the graph or how you draw this graph. And to do that, we need to complete the square. To complete the square, you're going to basically make sure that the coefficient of x squared is 1. It currently is, so we don't have to do any other changes. Then you're going to divide your b, you're going to multiply your b by a half. So our b currently is just 1, right? So you're going to have that b factor and then multiply the coefficient by a half. So you're going to have a half, square it, and then subtract it. So this is basically 0. So like we're adding and subtracting the same thing. So we haven't changed the equation. And finally, you're just going to have the c, which was originally there. But now we're going to group this stuff differently. So if you group this section together, then it should lead you to this bracket here, which is x plus a half. So you just take x from there and this exactly as it is, then square that. And you can verify that expanding this bracket takes you back to this portion. So that covers up for this portion there. Then on the outside, you're just going to add what you have. So a half squared is 1 over 4. 1 minus 1 over 4 should be 3 over 4, which means on the outside, we just have 3 over 4. So this is our new equation, and from this, we can find the turning point. So the turning point of this thing, TP, would be negative a half and 3 over 4. And if you try to visualize it, or if you try to look at it, it looks something like this. It's somewhere there, right? It's 3 over 4 is a positive, and it turns there, and the A is positive. It's 1, which means our graph is actually going in that direction, or it's a smiley face. As you can see, it never crosses the x-axis, and we don't really have to worry about sections where it's below, which is that point, because it never goes there. And the question is asking us, where does this graph or this function have positive y values, or where is it greater than 0? And the answer is everywhere. Its turning point is over there, and it just goes up from there. And all of the y values which you look at on the graph going up are positive y values, which means to answer this question, this is how we're going to give it. So for all x values, from negative infinity to positive infinity, you're basically going to have y values which are positive, which satisfies that condition. So x is an element of negative infinity to positive infinity with round brackets to show that we don't include those. And that is how you'd answer this question.